In this video, I want to talk about a concept called sharding. If you've ever wondered how huge systems like databases and blockchain networks can handle massive amounts of data without slowing down, then sharding is one of the key techniques that make that possible. So let's get into what sharding is, why it matters, and how it works so that you come out of this video understanding what this concept is, and this will allow you to maybe apply it in your job or pass job interviews and apply it to your systems design understanding. Okay? So let's start with the basics. Sharding is a method of partitioning data in large systems like databases into smaller, more manageable pieces called shards. Instead of having all the data stored on one big database, sharding allows you to spread the data across multiple servers or nodes. Each shard holds a unique part of the data, and together they make up the whole system. It's like slicing a large pizza. Each slice is part of the pizza, but it's easier to handle and consume than dealing with the whole thing at once. So, why is sharding important? Why do we need it? Well, as databases grow, it becomes harder to manage all that data efficiently. Think about how large-scale applications like Facebook, Google, Amazon deal with millions of users and billions of data points. If they tried to store all that data in a single database, it would slow down significantly, it would cause delays, cause outages. And here's where sharding comes in to solve the problem. One is performance improvement. With sharding, queries and operations can be performed faster because each node or server only handles a part of the total data. Two is scalability. If you need to handle more users, no problem. Just add more shards to distribute the data, allowing the system to grow efficiently. And then three is fault tolerance. If one shard fails, the entire system doesn't necessarily go down. The other shards continue working, keeping the system a little bit more resilient. So, how does sharding work? Sharding can be implemented in various ways depending on the type of system, but in general, here's how it works. Number one, data partitioning. You need to decide how to split up the data. This can be done by user ID, geographic location, or other criteria depending on the application. For example, you could put all the data from users with IDs 1 to 1,000 in one shard, 1,001 to 2,000 in another, and so on. Number two is mapping. The system keeps track of which data belongs to which shard. This way, when a user makes a request, it knows exactly which shard to retrieve the data from. And number three is distributing workloads. Each shard operates independently of the others, processing its own queries, storing its own data, and returning results when requested. A common example is in distributed databases like MongoDB or Cassandra. These databases allow for horizontal scaling using sharding so that you can store more data across different servers as the system grows. Now let's quickly go over the different types of sharding. So I'll give you three. One is range-based sharding. This is where data is divided based on a specific range of values. For instance, if you're sharding based on customer IDs, as I mentioned, shard 1 might handle customer IDs 1 to 1,000, shard 2 with IDs 1,001 to 2,000, shard 3 with IDs 2,001 to 3,000, and so on. Two is hash-based sharding. In this type, a hash function is applied to the data, and the result determines which shard it goes to. This is great for distributing the load evenly. And number three is geo-based sharding. Sometimes data can be sharded based on geographical regions. If your users are spread across the world, you might have a shard for North America, another for Europe, and so on. Now, let's talk about the challenges of sharding, because obviously, there are pros and cons to everything. And while sharding helps with scalability and performance, it can also introduce complexity into your system, right? There's a data management component, managing Multiple shards means you need to ensure that data is distributed evenly and correctly. If one shard becomes too large or overloaded, it can cause bottlenecks. Another thing is rebalancing. Over time, some shards might become much larger than others, leading to the need to rebalance the data. This can be a tricky process without causing downtime. Another aspect of this is cross-shard queries. So sometimes you need to query data across multiple shards, which can slow down the system if not handled correctly and efficiently, and it's a little bit more complex as well. So those are kind of the pros and cons here. Now, I thought I'd mention sharding in blockchain real quick, because sharding isn't just used in databases. It's also a hot topic in the blockchain world, particularly with networks like Ethereum 2.0. So in blockchain, sharding helps scale the network by splitting the entire blockchain into smaller pieces. This allows nodes to process only a fraction of the blockchain's transactions, improving speed and reducing congestion. It's one of the solutions to the scalability problem in blockchains, where more users and more transactions need to be processed without slowing the system down. So to wrap it up, sharding is a critical concept for scaling large databases and distributed systems. It splits data into smaller pieces or shards, making it easier to manage, faster to query, and more resilient to failures. Whether it's in large-scale web apps, distributed databases, or even blockchain networks, sharding plays a crucial role in handling the massive amounts of data we rely on today. If you found this explanation helpful, give it a thumbs up, and don't forget to subscribe for more deep dives into tech concepts. Thanks for watching, and I'll see you in the next video.